Welcome, Clarice. Thank you for joining. And welcome, Professor Agya Das from Wisconsin University, Platteville.
Hi, Ganesan. Hope you can hear me.
Yeah, let us give 1 more minute for people to join. Hold on. I think it looks like I have some network issue. I think it should be okay. Yeah. Thanks, Clarice. And we got already like 92 participants joined actually, and there are like 400 people registered. Let's hope more than 100 people will be part of this presentation.
Good. Congratulations, Dr. Ganeshan.
Oh, thank you, sir. Thank you for all your support too.
Dr.
So
Ganeshan, Dr. Anisha.
Yeah,
Anisha is just only 1 minute. Dr. Anisha, the Chief Executive Officer and Chairman, is a well-known cardiologist practicing in the western part of US. I think you must be knowing. Just I wanted to tell you, he's a reputed cardiologist. He's a professional medical doctor. I think it's great. I mean, a coincidence that a medical doctor is participating in such an event. I think it's certainly, I consider it is one of the best things.
Yeah, in collaboration with Dr. Anisha and SVM, we are running this program too, and also your involvement is also highly appreciated. Thank you for that.
Thank you.
Dr. Anisha initiated this, the healthcare related AI and all the stuff. And I thought okay, let's go and do something and, relevant to, the current situation, all worldwide, and see what we can do from this group, And we got already
good. Yeah, good.
108 participants, and also we are live on YouTube. We have that link there available. So please do take a look at it. And okay, let's get started. In interest of timing, I'd like to invite all the panelists. The very important, the panelists here, Dr. Anisha, Dr. Murli Krishna, Dr. Vincent, and Dr. Agya. And thanks for your, wonderful time here, going to spend, and probably there is an opportunity for you to speak in this, webinar too. And thanks for Clarice as well as Ander, who are going to speak for next 1.5 hours. And it's all about AI in healthcare. The right time, we are going to do this presentation and see what we can do, to the society, going forward worldwide. And with this, I'd like to invite Clarice to start the presentation. Clarice, please go ahead.
Okay, let me make sure I can share my screen.
Good to go, Clarice.
Okay, great. Again, thank you for inviting me to present. I'm a executive IT architect in IBM. We work with clients to come up with solutions to advance their cloud and AI goals. And this presentation will focus specifically on healthcare and AI in healthcare, and where we've seen use cases and opportunities to improve time to science, basically. So I'm going to cover a couple healthcare use cases. Then I'll talk about IBM's approach to AI, and we call that the AI ladder, and it's a full life cycle to get at scale. And I'll conclude with some AI at scale comments on what it takes to build an entire ecosystem to leverage AI in healthcare. So as you know, it's the fastest growing workload, not just in healthcare, but across the board. And there's a lot of talk about artificial intelligence in general, and it's nothing new, really. It's been around for many decades, and systems have been used for machine learning to to improve analytics and predictions for many years as well. What's really new here is the growth in deep learning algorithms and the computational capabilities with GPUs and the ability of managing all this data growth to train these deep learning models that have really created a new explosion in AI. So between that and the innovation of leveraging these techniques, we're seeing AI permeate many enterprises, many research areas, and so on. So what do we need when we talk about analytics modernization relative to AI? For many years, the idea has always been to get from data to action. And the human contribution to this was very intense originally, where we just had systems that could keep track of what had happened in the past. Over time, our capabilities became wiser and introduced predictive and prescriptive analytics. What will happen and what should we do? What AI brings to the table is a new era of cognitive learning, where you're learning dynamically. You have the systems that are learning, and you're reducing the amount of human input to just the final important decisions to trigger the actions that you get from the insights from your data. In healthcare, we see that as well, and we've got a reference architecture that looks at all the aspects of how to leverage AI in the framework that you have. So you've got medical tasks that need to get completed. You've got applications and models that leverage the insights of your data. You've got a data hub, and of course you have to orchestrate all of this coming together. And there's AI opportunity across the board through all of these layers of a reference architecture that you would build to get your insights. We see in general 3 broad cases of AI. There's more traditional structured use cases. This is when you've got big data, lots of rows, lots of columns, and you can leverage AI to get more accuracy, more insights quicker from your raw data. We've got the new era of computer vision use cases, and this is the deep learning techniques that I mentioned earlier. It's somewhat a magic, it's black box, it's an evolution of algorithms that are better than the human eye that allow all of these use cases to flourish. And then finally, you've got maybe the AI that you see in your everyday life relative to purchases you make online, support systems when you call a help desk. This is all tied to natural language processing. There's a translation AI. There's a lot of basically anything to process language. And you'll see chatbots in this category. You'll see recommendation engines in this category very often for retailers. And you basically have these types of use cases that you can apply to your workflow and decide what type of algorithms and what type of AI would make the most sense in a specific scenario. And those scenarios are through a number of categories. What we talk about when we talk about AI is narrow AI, and we differentiate that with broad AI and general AI. General AI is the work of science fiction. We're not there yet. We may never get there. And it's full automation. We are somewhere between narrow and broad AI. Narrow AI are tasks that are very, very specific and achieve a single goal. Broad AI has more characteristics that make those systems more robust, transferable, explainable, which is very, very important in many industries, including healthcare, including financial services, and scalable. So our goal is to take narrow AI scenarios, generalize them, make them broad, make them robust, explainable, and some systems that we can trust. So when you're looking for where to apply AI, of course, anywhere there's big complex systems, too much data to process manually, big complex systems is a great opportunity. Any opportunity for personalization where the information, the data that you have is very specific and you want to provide very specific solutions to your patient, to your clients, any opportunity for automation, anything that can be done by an expert. If it can be described, there's probably an AI system that can augment that expertise and help generate faster insights, because you're taking some of the rote functions out and leaving the expertise to the experts. Simulating relationships, we talked about visual recognition, pattern recognition. Some of those visual models don't necessarily even need to be images, as long as you can translate a concept into an image, like sound with spectrograms or satellite data or anything that, that you can put into a mathematical function. Basically, you can do pattern detection. Chatbots, we mentioned, design of experiments. This has a big place in the world of high performance computing, where if you can find AI to reduce the number of simulations you do, you can get faster time to science there as well. And generally any type of optimization challenges. As I mentioned, this is across the board. Of course, we see a lot in life sciences, but the idea is to be more productive, more efficient, and possibly do things that are impossible to do today. And that's where AI is revolutionizing every single industry. So let's go into a little bit more detail in terms of healthcare and some examples on that. Of course, today we're facing some huge challenges with COVID in particular. The reliance on genomics, molecular simulation, biomolecular structure, medical diagnostics, data fusion, and bioinformatics all are opportunities for artificial intelligence to attack the solutions, the virus, and to come up with solutions. So we're starting to see AI in molecular drug discovery, genomics, and medical imaging processing. There still are many challenges tied to that. One is data overload. We've got too much data, and it's hard to analyze and to get to the most important components of your data and to be able to recognize that. App chaos, of course, thousands of applications, so many workflows. Every system has its own rules, and of course, performance and cost. When you're running a research center, you need to factor in budgets and be able to manage that as a full system. We're seeing definitely the convergence of HPC and AI, and what's interesting is we're seeing it in two ways. On the one hand, we've got an explosion of data through sensors, through outputs of simulations, and so on. And we've got insights that we want to get to. Traditional HPC has been about analysis of results of simulations. And on the other hand, there's AI that will look for patterns, and you can build models to generate those patterns. So there's the two that are separate, but there's also a combination, which I mentioned earlier, where you can apply AI to your traditional techniques and accelerate your time to results. So let's talk a little bit more about medical imaging. There's many examples at this point on being able to do more with AI. This is an example from work that was done at Vanderbilt School of Medicine and Washington University School of Medicine, where they were able to process 1,300 MRI images in just 2 hours compared to a 40-hour time to end a job that it would have taken with a traditional approach. We've seen success with melanoma detection. This is just a very simple visual use case where we've been able to just take a picture right then and there of a suspicious lesion image and determine whether it was atypical, benign, or needed further analysis. The advantage here is that you've got the full body of knowledge with many images that the system was trained on to get very high accuracy. So you can, with your patient, support a quick decision for next steps with the backing of that information behind you. So this is a typical just simple image model example, and different techniques resulted to even better and better accuracy. So possibly more accurate than the human eye or the first impression. Another example of image recognition is with the cryogenic electronic microscope. So cryo-EM, as you know, generates a huge amount of data. So 5 terabytes of images per data, typically for one instrument. And so being able to manage and evaluate that data takes a lot of resources and a lot of time. The system at MIT was, I believe, a 64-node system, was able to show that it could manage 100 cryo-EM high-resolution image workloads in parallel and generate much faster time to results on that with so the advantage here is that you're now getting more out of your very expensive instrument and getting more results faster from that. Of course, relative to drug discovery and analysis of molecules, simulation of atoms requires a lot of computational resource. And so the traditional HPC approach to this is to get faster CPUs and get workloads that can leverage GPUs to accelerate the simulations. That takes a full HPC cluster, and not only compute resources, but of course memory and network bandwidth is critical when you size a system for that. And what we're introducing is also techniques to reduce the amount of work that you do in the first place. So allowing those resources to move on to the next grand challenge, or to reduce the number of resources that you need and fit within your budgets. So this is called Bayesian optimization. And we've seen some examples where we've been able to do a lot faster work in completing a project, going from days to months in terms of reducing the amount of work that gets done. And so this is an example where the workflow used a third of the calculations it previously used to achieve 4 orders of magnitude higher resolution in that use case. So again, in terms of approach, this is Bayesian optimization is about finding the fastest path to your local maxima or minima. and being able to get to results faster, better, and cheaper. And there's an example here with GlaxoSmithKline, where they reduced their screen workload from 20K experiments to 200. And a study that was done relative to other acceleration techniques to show that they were able to reduce their drug discovery workflow timing as well. Finally, in terms of examples, relative to optimizing precision genomics, having the right data structure is really critical. So in this case, they were able to complete 100,000 computing tasks with millions of files and directories without experiencing any system downtime. So they had a very good structure relative to that, using ESS, which is a generalized parallel file system appliance. So IBM's approach to this and the use cases we just talked about, you saw that there's different components to get to results. The data piece with collecting and organizing the data, being able to build trusted models at scale is the analyze approach to this. So you collect, you organize, you analyze, and then clearly being able to use these AI models that you develop, which we call infuse. You might think of it as deploying the models across all your workflows and basically inferencing. So you're taking advantage of your models that you've developed and you're satisfied with the accuracy, and you infuse into your processes. So that's the approach that IBM has taken. It's the AI ladder. We have a book published on that. And the idea is data of every type, regardless of where it lives, and deploying your AI in a hybrid multi-cloud world, whether it's on your on-prem systems, in appliances, out on the edge, in the clouds, public or private. Being able to take advantage of AI is really your goal. So relative to healthcare, of course, biological data requires multiple workflows to get through all that data. So you've got genomic sequencing data, you have biomarker identification, you've got structural bioinformatics, biodata modeling and statistical analysis, and as we mentioned, medical image processing, and finally, visualization. So across the board in all the research you do, there's an opportunity for managing that data and leveraging AI for that. So there's multiple challenges that you come through. Of course, the data explosion, the amount of storage and how you govern that storage, the computation we talked about already in terms of requiring very intense computation. And of course, the idea is to get to highly optimized pipelines with all the components coming together. When we talk about AI, we also talk about the data pipeline that goes along with the AI. So there's the AI piece itself, which is developing the model and making sure that you've got a platform to use the model in terms of training and moving to inference. But from a data perspective, you need to plan how to get your data in, whether you need transient storage, how you're ingesting, if you need to ingest real time, how you're going to extract, transform, and load your data, where you're going to store it, whether for archive or making it accessible in data lakes or data oceans to feed to your training models and your simulations. And as you know, it's a very iterative process because you learn from the the models that don't predict things correctly, you feed that back into the system, or as you get new information, new data, you feed that back into your training systems. So the storage component of a solution of an architecture is very, very important, and it permeates through all the steps of the AI ladder. And these are things to factor in. One additional piece here is the metadata, which we'll talk about. I skipped this. This is understanding where your data sources come from. There's a lot more than just domain knowledge at this point. There's information from sensors, from social data, third-party data. There's just so much data available, and being able to think about what your data is very important. And understanding where the data is, where the metadata comes in. And in the medical field, there's definitely a lot of information that goes along with the information. So examples of that are with images, understanding where and when it was taken, what resolution, what kind of markers, what kind of tags you've associated with that data. These are all information that can feed into AI systems to augment how you build your models and what you use to train the models. So having the capability to tag information, to find your data via metadata, and to be able to manage activation, visualization, and ingest are all factors to consider when you're looking at your data for AI architecture in the healthcare field. Common considerations that we see independent of industry, especially in the training and inference aspects of your AI models, is looking for robustness, being able to leverage open source, and in some cases you need bandwidth, in some cases you need latency. So all these components come into play as you build your AI architecture. In terms of software, you also have the opportunity. I mentioned a little bit about open frameworks. This seems to be the industry direction. PyTorch, TensorFlow are typically used to build AI models. We see a lot of Red Hat management for the AI infrastructure, and we see a lot in terms of parallelism to take advantage of things like Horvath, Dask, and so on. One example I wanted to bring up relative to tools and examples is building up an Anaconda environment for the cryo-EM analysis I mentioned earlier. You have a database, you've got compute nodes, you've got a repository, you've got the users that can access the tools and the information that you have through an Anaconda server with a nice web interface that manages the computational examples. So these are just one example of many, many different tools that you can look at when you're managing your workload. The IBM approach has also been tied to open source, and I just wanted to mention that if you're interested on running some of the open source frameworks on Power Architecture, there's a third party that called OpenCE, and that's managed for open source. So let me just conclude now relative to the final thoughts here. Is a lot goes on into infusing AI into your workflows. And it's not just building the model, it's also managing the data and having the right tools to integrate with your traditional HPC and your job scheduling, and leveraging the AI requires trust. So as you're developing your AI systems, always consider whether you're building systems that are fair, easy to understand, secure, and accountable. So fairness, explainability, adversarial robustness, meaning no one else can tamper with it, and transparency are all additional factors, additional dimensions that we really haven't even covered here when we're talking about AI infrastructure to factor in. So I'd like to thank you and open it up to back to the panel for discussion.
Yeah, thank you, Clarice, for the detailed presentations on in healthcare, and it's a good one, a good eye opener. And thanks for that. I really appreciate all your time, spending here for this, kind of series of webinar in open power world. And I would like to invite, the Dr. Anisha to say a few words and, maybe ask questions or anything. Dr. Anisha, please go ahead.
Hi, good morning here from United States. I'm in Los Angeles, and good evening to everybody in India. Thank you very much for attending. So I'm an interventional cardiologist, and over the years, of course, I have practiced leading cardiology, and AI has become a very integral part of the evolution of what we are doing right now. I'll just take a simple example, and of course, this everybody knows, but you take a simple EKG, and the electrocardiogram is a focus, like a narrow band of AI, where the computers can interpret the EKG, and it is got a 99 or 98 to 99% accuracy, especially if it is normal. So one can see that how it has changed the entire landscape of a simple cardiology management, which we, of course, we now take it for granted, because what used to happen in my school days that we didn't have these things of 35, 40 years ago, and we had to read each and every EKG by hand and interpret them. And by the time the diagnosis would come to the bedside, it would take at least 24 hours sometimes. Now it's immediate in the next few seconds. I mean, this is just a basic understanding of what an EKG can be all about. So I think this is it's a evolutionary changes that have been consistently happening. And as you could see today with the MRI changes and genomics and images, etc., there is going to be a quantum jump in the diagnosis and the accuracy, and therefore the effect on the population at large. Now, being in India, and of course, I run the Smart Village movement, and we have several verticals, including healthcare, agriculture, education, good living, transportation, security, and so many different parts of it. And we, of course, want to make the villages smart. And healthcare, without its infrastructure, we cannot make the villages smart. So what we have done right now is that we are trying to take care of population management. And this is some simple example. And why it is important, it's important for the people who, especially for the students who may come in, that there's a tremendous broadening of the healthcare landscape. 35, 40 years ago, parents would tell us, please become a doctor. Okay, it's a very good profession, please become a doctor. But nowadays, medicine is not only doing healthcare directly, but there's a broadening because of artificial intelligence and many computational skills that you can go to deep learning, machine learning, and creating all different kinds of a tremendous amount of broadening of the healthcare spectrum. And the important thing was that because of the time that it took to become a doctor, medicine has traditionally been a scarce resource. You can find doctors, you can find specialists. I've heard that 73% of people in India don't have doctors within 10 miles of where they live. And therefore, it's very important that we do population management, and AI can form a great way to take care of this thing so that we can have prevention and growth of the physical as well as the mental stature of a human being, rather than just treating diseases. And we at Smart Village Movement have taken a pilot study of about 100 to 150,000 people in the northeastern region of state of Meghalaya, where we are trying to now get about 40 parameters to create the World Health Organization standards. Now you can imagine to take a population in the rural community and trying to do this on paper would be extremely difficult. How would you really manage it? And AI and its applications in the most rudimentary form can transform this entire situation to make it a positive impact on the population of the people. So I think this is just fantastic, and I would just encourage people to really start thinking very seriously about the kind of careers that are possible within the healthcare industry, and therefore the basics of healthcare and the basics of this computational processes must be taken into consideration. We at Smart Village Movement are now collaborating with IBM to create a course where 150 students will come up and get a 3-month course in IBM to learn artificial intelligence and machine learning, deep learning, etc., so that the students can get encouraged to really participate in these things. And hopefully the students from the villages and students who are also in tier 2 and tier 3 cities, but whose parents live in villages, can participate in this situation, because that will go around in terms of really making the villages more efficient. We are dealing with several companies, including IBM and Microsoft and Salesforce, that we want to really participate in growing the healthcare landscape in India. So I'm just totally tickled by what is really going on right now. And I really thank Clarice for giving a broad overview of what happened, what's going on with IBM. And we welcome the continuous collaboration and partnership with IBM and Ganeshan. Thank you, Mr. Ganeshan. And of course, Professor Murali Krishna is with Smart Village Movement. He forms a very important part of our educational series through Berkeley and with all the Indian institutions. And it's great that we can carry it to the next level. Thank you.
Thank you. Thank you, Mr. Anil. Thank you for the great collaboration too. And looking forward to work with you all and see how we can help each other. And also, thanks for, the wonderful platform, the Smart Village Movement, and also, many villages in India, to take advantage of it. And this is a great opportunity for everyone to collaborate also in this platform. Thank you, Mr. Anil. And I would like to invite Dr. Murali to say a few words and probably ask questions, related to the presentation, with Clarice and all. Mr. Murali, please.
Yeah, Dr. Ganeshan, I'm here. I think we had a very interesting presentation about the automation of the automation by Dr. Clarice. One of the most important issues Dr. Clarice handled is related to the specifically data. And what is the issue specifically, most important aspect is the landscape of the AI software. So in terms of ease of use, or in terms of how do you optimize the resources? These are the two important things I consider as very significant. Maybe sometime later, Dr. Clarice can just throw some light on how do you address the issues of the landscape of the software. That's one specific issue. Then other aspect I would like to mention is this, considering the importance of health as a general issue. And in India, there are several programs in the government on public health management, basically. So health is a region as taken in a spatial domain. And the technologies like the satellite technology, geospatial technology, have done contribute significantly in prediction of the communicable diseases. But if you see the trend in the world as a general issue, and in India, there are several programs. Am I?
Yeah. Go ahead, sir.
Yeah, there are several issues coming up. The communicable disease, addressed significantly, by which the space technology has played a very important role in prediction of the diseases and the spatial distribution of the communicable diseases. Established models are there, but not significant work has been done on the non-communicable diseases aspects. Basically, because now, even globally, the percentage of people affected by communicable disease is slowly decreasing, but it is increasing at an alarming rate, how the non-communicable diseases are specifically affecting the hypertension, obesity, physical inactivity, or diabetes, etc., cancer, etc. How they are. This is where the population health management plays a very, very significant role. And some of the studies we carried out at Udanam in Andhra Pradesh related to the chronic kidney disease, in which the database of individuals have been studied, used in terms of application of deep learning models, etc., which are on the progress, of course. This, I wanted to say this, the population health management becomes a very, very significant part when you are addressing the non-communicable diseases, specifically in the context of availability of tools like artificial intelligence from IBM platform and the Open Power Foundation, about which I'll again take another opportunity of Dr. from Ganeshan to speak for a couple of minutes later. But I think this is very, very important for healthcare, disease mapping, and hazard vulnerability assessment, etc. This is my specific issue, and specifically the landscape issue of the software in terms of its use of the use and the optimization of the resources with reference to the AI software. I think she has touched a very, very detailed manner, but specifically this is one of the most important points which is being faced by the students in terms of the ease of the use. I think class can tell now or later this particular, clarify this particular issue. Thank you.
Yeah, thank you, Dr. Murali, for the the response to the the Clarice presentation, as well as the general overview about the IBM, your collaboration with IBM and Open Power. Thank you very much for that. And we have a couple of questions also, like the panel. I mean, the participants asking some questions. Hold on, let me see. Yeah,
I didn't see that. Yeah,
I think I'm going to open up the questions for the the participants. Participants, Akshay Raja, you please go ahead and ask the question. Akshay, you have any questions for the panelists as well as the speaker? Yeah, looks like some issues. Okay, let's move on. I'm not going to be keen on this right now. So please, participants, do you have any questions for the first presenter, Clarice, who talked about a lot of details about AI hardware and software and all? Hello.
There is one question here. What is population health management?
Yeah, yes, true. Yeah.
Okay, so
that is, yeah. Please go ahead, Dr. Anil.
Okay, so population health management means creating the management of people rather than patients. So what happens is this, that for example, when you see in developing countries, the nutritional aspect, the build, all these things sometimes is substandard. And in order to manage the population in a positive manner, you need to start getting interventions at a very young age and keep on monitoring it. Now, say, for example, we are talking about a situation where we have a situation for diabetes. So say a person's got diabetes and they're trying to manage their blood glucose. And if you just manage the blood glucose and take a blood glucose in the morning, and you may find that the blood glucose is 110. And after that, when the breakfast comes in, they eat a lot of sweets, bread, and all sorts of things. And you'll find that soon the blood glucose goes up to 250 or 300. At that stage, of course, the productivity goes down in general. Person feels lousy, is unable to concentrate, unable to work. His productivity kind of is decreasing. So what AI can do is that we can actually, by AI, take the entire population and send signals every day. Did you measure your blood glucose today? And teach them what to eat, what not to eat. And so AI can literally completely go there and just take care of it. And then, of course, you do the data management, by which if the hemoglobin A1C, which is a test that is done in order to see what is your blood glucose level over 2 months. So say for example, the normal hemoglobin A1C is about say 5.7 actually. But if it's less than 7, then your blood glucose average is 185. So one day you may have 100, but the next day you can have 300. But still your average is 185. And it's shown that if the number is below that level, the complication rates decrease dramatically. So now what happens is that issues of renal failure, amputation, heart attacks, stroke, hypertension, all these vascular diseases, in mental illnesses can be significantly curtailed to a great extent. So what AI can do is to try to do the entire population management artificially, by which it can get the data, give automatically the information to the patients, ask them for to do their blood sugars every day or to do the hemoglobin A1C in the next 2.5 or 3 months, so that the data can come to the working group, and the working group can do the interventions that are required, again by AI, to make sure that the patients do cooperate and comply with their management. Now, that is very important. You can just imagine the amount of kidney failure that's happening in the world today, especially India, and people have to go to dialysis, and the entire family's economic as well as the happiness is really compromised. So at the end of the day, we want to manage the entire population in such a way that the population becomes more compliant and takes care of them. I mean, you can have a simple thing like doing folic acid deficiency or vitamin D deficiency. And if there's a blood test being done and you know that is deficient, and I'll tell you, 70% of people have vitamin D deficiency and they don't even know that. But it is so important to have these deficiencies taken care of that AI can help in the entire spectrum rather than doing on paper and one-on-one. I mean, hardly anybody goes to a doctor these days for preventive healthcare. They do more and more often for issues like disease management. So one has to really shift the paradigm to prevention and positive healthcare management and prevention for future diseases rather than going for disease curation. Thank you.
Thank you, sir. Thank you. Good explanation. And I hope Nalini Joseph would have been happy with this detailed explanation. And we have several questions on the Q&A and chat window also. In interest of timing, I want to give opportunity for the panelists to talk, say a few words, and then move on to the next presentation. And while they are doing it, do respond to the questions, through the Q&A and chat window, the corresponding, the panelists as well as, the speakers. As a next panelist, I'd like to invite Professor Agya to say a few words about healthcare, AI, and what is his vision. Professor Agya, please go ahead. Agya is from Wisconsin University. Yep, Platteville.
Mm-hmm. Thanks, Ganesan, for the wonderful webinar. And I would like to thank, first of all, to all the speakers who have shared all their visions through this SBM and healthcare and AI. And well, now I have one quick question to all the speakers, specifically considering the Indian rural health market, because the vision is for smart villages movement. I am actually working on this telemedicine side of the projects in rural India's in West Bengal side. So one issue that I have found is like the persons in the rural area, they are not really very much tech savvy in nature. So, and also as Dr. Shah told that in India, there is a very lower number of doctor to patient ratio. So there are lots of problems. So in one hand, we can see that, well, doctors cannot individually see the patients. And on the other hand, we can see that the type of software that we are trying to introduce, there is a steep learning curve. And honestly, with the current policies by government of India that there will be the co-op practitioners, the midwives, and all, they are all coming into this healthcare domain. So my question is, what is the vision of SVM? Like, would you like to create a totally new workforce who are really keen onto this technology, or are you trying to educate these midwives or quack practitioners to get accustomed to this AI-based software? Or yeah, I mean, you can understand, right? I mean, how are you going to manage this entire thing? In one side, the lower doctor-patient ratio, and in other side, little bit of friction in adopting the technology.
Thank you for that question. I think it's a very interesting question, and we all are pondering what to do. But what our solution is that at the present time, we've got inquiries from at least a couple of states, including Andhra Pradesh as well as Meghalaya. And what we are trying to do is to create a model, and we've got several companies who are participating now, where the questions of the positive management and to shift the paradigm from treating to prevention. Now, the way it can be, of course, we have to have the cooperation of the government. So Smart Village movement does not really work without government intervention and support. And I'm very happy to say that Meghalaya has been at the forefront of this, and they have really, I mean, the chief minister was from Wharton, I mean, he understands some of these things. And what he has done is that he has given us a free hand to really participate, and the secretaries in health and their nodal officers are very, very interactive and active in this sphere. And what they do is that they have given us the pilot right now and told us that eventually please go to the entire state. So what will happen? What will happen is that the people will become less stunted, the patient will become healthier, the communicable diseases will be addressed too, and of course the 40 parameters that we are working on. So in the United States, for example, over the last 10, 15 years, about 7,500 hospitals have closed. So why would the hospitals close? And even more hospitals would close were it not for the US government to support the hospitals by paying them financial resources. So what is happening is that when you put this kind of a management together, and of course it requires a lot of people simultaneously, and the population is not really trained to start working on their smartphones, even though it's now getting tremendous encouragement and young people are on it. But what will happen is that every village will have a ASHA worker or somebody, or maybe manage from the thing. And what we do, our model is not to really do the things ourselves. We bring businesses inside. So, for example, we've got a company known as Janitri, which will take care of the maternal mortality rates and children mortality rate. And what they do is that they monitor the patient, the woman's pregnancy, and put the right interventions at the right time, so that the maternal mortality rate during pregnancy decreases considerably. So it's very important to have business participate in it rather than we creating our own force, because creating your own force is not going to work in the short term. It is going to work only it's going to be that the businesses should take care of the things of what they are really doing them. So this is just one part of it. Now, if there is no business doing that, then obviously we'll put in our own workforce to take care of those things. I hope it answers some of your questions right now. But it's a very big topic, and we can talk offline. And of course, telemedicine is only one part of it. Telemedicine is
exactly
the simplest form of AI. I think what we have to do is to go much beyond that in terms of population management.
Yep.
Thank you.
Thank you. I mean, it actually answered some of my question, and thanks for the wonderful answer. Thank you.
Yeah, thank you, Professor Agya, and thanks, Anisha, again, responding to the question. And there are a bunch of questions, getting posted in the Q&A. Please, do take care of that. And there are a lot of questions related to healthcare as well as AI related to. Please, do take care of it. And before we go to the second speaker, I'd like to invite Dr. Vincent from PSNA, one of the South Indian colleges, good colleges, and collaborating with IBM. And Dr. Vincent, please go ahead and say a few words
Yeah,
about your involvement.
yeah, it's a wonderful the webinar arranged by Ms. Dr. Ganeshan from IBM, and I think Dr. Clarice given a wonderful talk about the AA, and I think Dr. Anisha is given. I think he's doing a lot of work in India about the AA, and particularly in the Meghalaya about the population management, other things. So all the panelists and the attendees are, I think this is the wonderful session. And I am Professor Vincent from PSNA College and is Anna University, and we are doing a research with working about the optimization and as well as the convolution, deep learning neural network, and other things. In the optimization, we work with the genetic algorithm and so on. And also, I think Dr. Clarice discuss about the using of medical images by using the deep neural network and as a deep learning and other things. But I think Professor Orgia also, I think, is pointed out, but while doing the problem, what we are facing out, the data. If we have a medical data, suppose working with of the deep learning convolution neural network, other domain, the getting the data is a very difficult while doing the research and do with publishing in a good the Elsevier journals or other IEEE journals and other things. So the data is the one of the issues. And one more thing, I think I think from the Anil Shah sir, Dr. Anil Shah sir, here in our this is comes around the PSNA college comes around the South India, and we are collaborating with IIT Madras to do some social relevant project, and we monitor the people, the health, and to the rural villages, and we were there with the IIT professors and the team of the students. We went there, and we developed with some of the about the women pregnancy parameters, identifying with the Google Developer Club from Madurai also. Is it possible collaborate with your team, Dr. Anil Shah sir, about talking about the smart village smart village movement in the Meghalaya? Is it possible to give collaboration with the Tamil Nadu, with the Ganeshan sir, so that we can do some work with the, since we are having the good students, potential students who are available, and the research people are available. So is it possible to collaborate with you, do some work in the tribal villages in nearby South India?
Yes,
Professor
absolutely.
Anis,
Yeah,
yeah.
absolutely. So we should talk offline. I'll
Yes,
be
sir.
so we can talk offline to see. I mean, there is a real
Yes,
model of
sir.
how we do it. So we have to involve the
Yes, sir.
government. Government agrees to do it. There's no question about it. Absolutely. More than
Oh,
happy to.
yeah, thank you.
Thank you, sir. Thank you, sir. Thank you,
Yeah,
sir. Thank you.
thank you, Professor Vincent. It's a good point. There are many villages, around India, can take, advantage of, the smart village movement too. Certainly, as a kind of a member for the last 4 years from my side, definitely, that's a moment, we all need to support, and, and also how we can take advantage, using that, to support the villages in India too. That's a good opportunity too. Thank you. Thank you, Dr.
Thank you,
Vincent,
sir.
for the good point. And I
Thank
know,
you, sir.
and there are still a lot of questions. So please, do take a look, panelists. Whatever you can, answer them. Let's move on to the second presenter. And we had, the Clarice as a leading presenter, for the AI in healthcare. And she leads, in the United States, a lot of customers, and a lot of, presentation to, probably in healthcare industry and many industries. And similarly, I have Ander Ochau from Europe. He leads, the cognitive computing area in Europe, multiple countries in Europe, and he's here with us, to share some of his, activities and some of his collaboration, with the healthcare and IBM and AI. Ms. Ander, please go ahead and start your presentation.
Okay, let me share my screen. Okay, I'm not sure if I'm sharing the right one.
Yes, that's right.
Okay, so see, is it okay now?
Yeah.
Okay, perfect. So thank you very much, everybody, for being here today.
It was better. It was better before.
Oh, right.
Sorry.
Because it's
No problem.
full screen. Yeah.
Like this?
There you go.
Yeah.
Perfect.
Thank you.
Perfect.
Thank you, Clarice, for pointing out. Thank you.
Okay,
Yeah.
well, yep, my name is Ander Ochoa. I'm Cognitive Systems Architect for IBM's PIGI, meaning I work mainly in the south of Europe for Spain, Portugal, Greece, and Israel, but I also collaborate from time to time with other countries. I'm an Open Power Foundation member, and I have been working for IBM since year 2000. And today I'm going to try to show you some of the tools that IBM is using in the healthcare, both hardware and software. And in order to do this, I have prepared a small agenda where I will try to explain how is the relationship between healthcare and IBM, and how IBM is using what we do best, which is using our skills and our tools, mainly our supercomputers, to fight against something. And then we will talk about those supercomputers building blocks, which is, I think it's really interesting. It's not, I'm not trying to make a detailed technical presentation. It will be quite light, so don't be afraid. Also, then we will talk a bit about the building blocks of those supercomputers, which are quite unique, and we will make a small summary of the benefits. Then we will go from the hardware to the software side. I'm going to try to show which is the latest tools that IBM is promoting to run AI workloads. And if we have enough time, I would love to make a small demo for so you can see in real time how we do things with AI. So without further ado, let's go here. Well, everybody is aware of the time we're living. We are living a very complicated time with this COVID-19 pandemic, and it's something that has become a very big problem worldwide. So IBM has seen this, and IBM has decided to put what IBM knows the best in the fight against this coronavirus pandemic. And what we have the best right now is our supercomputers. IBM has created some of the most powerful supercomputers in the world, and we have used them to fight against coronavirus. I have to say sorry because I don't have healthcare skills. I'm more an IT guy, but I have included as many links as I could in those slides. So those of you who are more in the healthcare industry, so you can understand way better than me how we are using them, because it has a lot of healthcare stuff there that we, the common humans, don't understand fully. But this is related mainly to the Summit supercomputer, which is located in the US. However, this help to the fight against coronavirus is not only in the US, it's worldwide. And for example, where I work from, in Spain, we have several examples, like Universitat Pompeu Fabra from Barcelona, that will lend them several supercomputers or several building blocks of those supercomputers, which are at the same time smaller supercomputers, to fight against this coronavirus. Also, from the Barcelona Supercomputing Center, who also have our technology, they also have been leading the fight against COVID-19. And not only against this virus thing is how we use our supercomputers. We have several examples. For example, in the north part of Spain, sorry that I couldn't add the name because we still don't have permission. We're trying to get it. But I personally sold them several computers to fight against rare diseases. And they are the same building blocks that we are using in those supercomputers. Also, we have several cases of hospital researching genomics, and we have a very particular one, which is quite well known, the Hospital Severo Ochoa, who are using them for protein folding molecular analysis. So those supercomputers and their building blocks are they are being used for a lot of stuff related to AI and healthcare all around the world. And this has been like this because IBM, and I'm really proud to say this, because IBM has been the number one company for 28 years in a row to create more patents. We have a really big research and development department called IBM Research, and they create amazing technology to fight against the world's worst things. For example, this COVID plague that we are fighting right now. And those specifically the supercomputers that we have right now, well, there is a list in internet called top 500, and they list the most powerful supercomputers in the world. We have been in position number 1 and 2 from 2018 to 2020. Just last year, we moved to position number 2 and 3 because there was a new supercomputer from Japan. But I have to say that this list is very dynamic, and it was a remarkable achievement to be 3 years in a row in number 1 and 2 positions. And also we have another supercomputer in position number 9 in Italy, here in south of Europe. And they all share exactly the same building blocks, as I have said before. Here we have the description of the one in Italy, and they all share the same building blocks, meaning that they have the same storage, they have the same processing types, and they have the same servers. So just the amount of power they provide is just, it just depends on the building blocks they have. We have also another example in Spain, in Barcelona, Mare Nostrum 4, the Barcelona Supercomputing Center Mare Nostrum 4. And so that you can see how powerful our building blocks are, Mare Nostrum 3 was built around x86 servers, and it was 30, without N, 30 racks of x86 servers, and they were providing 1 petaflop of processing power. We added just 3 racks of our servers, and we added 1.5 petaflops. This is the type of difference that our building blocks give to this AI industry. Also, we have the most powerful supercomputer, private supercomputer in the world. This is from Ford Total Fina, which is one French oil company. And of course, we built the one from the MIT, did it by John Cohn, who we have been collaborating with him so he could get this supercomputer, and we're really proud of this. Well, we have several other examples all around the world, which I'm not going to go because I think it's not the point of this presentation. But so you can see that this is something really common, really standard, and it's really powerful. And we are going to concentrate just slightly more in the building blocks of those supercomputers. It's just 3 slides. They are slightly more technical than the other ones, but don't be afraid, because I will try to make them as easy as possible. The building blocks of those supercomputers are the storage, here in the right side, the GPFS file system. This is how the old people from IBM, we call it. Now they call it a spectrum scale. And this is a shared storage where all the computers of the supercomputer can access at the same time. We are using a really high connection fabrics called Mellanox InfiniBand. We have very powerful servers inside those racks. They are based in the Open Power Foundation work. They are using Power 9 processors. And we are using NVIDIA GPUs. Okay, this is also really important for running AI workloads. Those are the servers, which they have really big advantages against the competition ones. But let me go to the last technical slide, which is this one. Those servers, they have two sockets, which are the ones in the middle called Power 9 CPU. And those sockets where they have the processors are linked to one InfiniBand adapter. This is like, we could call it a network adapter, but it's a really fast one that links to both sockets at the same time and allows us to move data from the memory of our server to the memory of another servers. And this is a huge advantage for what I'm going to explain you later. Also, I want you to see another advantage of those supercomputers. Some time ago, IBM and NVIDIA created a joint development program where they developed something called NVLink. The NVLink is the connection between GPUs. And this is like this in all the computers in the world. However, in our servers, which were created with AI in mind, they also use the NVLink to connect the GPU and the CPU. And have this in mind because it's going to be the main thing to have the advantage of what I'm going to explain you later, okay? Both advantages, the one that allows us to exchange data from memory to memory, and the one that allows us to access the GPUs from the CPU so fast. So let's talk about the unique advantages of those servers. And those are software-related advantages, okay? And they are going to make use of what we show in the last slide. For example, large memory support. And forget what you can see in the slide, okay? It's just there as a reference, just concentrating on what I'm going to try to explain. When we are talking about AI, we use GPUs, and those GPUs usually have 16 gigs of RAM, 32, 48, whatever, but it's a limited space. In our servers, as we connect the CPU with the GPU so fast, we can access the main memory of the system from the GPU really fast. This allows us to use as much memory as the system has to feed the GPU. This allows us to make things like this. Using the same GPU, our servers can make trainings almost 4 times faster. Okay, this is just one example. But we're talking about healthcare, and it's good to have training times faster, and yeah, whatever. But the most important thing is that by using this huge amount of RAM, we can use medical images that have 4 times the resolution, from 4 to 10 times the resolution. And in AI, when we are dealing with AI in healthcare and images, of course, there is one truth that nobody can rebate. The more resolution you have, the better. And in this case, by using this unique advantage, you can have up to 10 times more resolution. This is something really good for healthcare. I have included several links for those of you who may be interested in knowing more about this type of advantage. Also, we're going to talk about the second thing that we show in the first slide, the connectivity between the memory to memory of those servers. Well, directly from IBM Research have created something called distributed deep learning. And what's this? I will try to explain. This means that so far, when we were running one training in one machine, we only could use the GPUs that we had in this machine. If we had 4 GPUs, we could use 1, 2, 3, or 4, but we couldn't use more than 4. However, by using this distributed deep learning piece of software, we can make use of the GPUs of another servers. This creates parallel computing. And one example of this is one training time that I think this was for Microsoft. They had a world record for one training, and they could make it with one system in 16 days. They could only use one system because there was no other solution to make it in parallel. And we created DLL, and we were able to run it in 64 systems. As you can see, it goes from 16 days to 7 hours. This is almost 60 times faster. Obviously, this is one example, okay? But so you can see how good this technology is. And also for those of you who are deep inside the technical stuff and AI, you can see here how the efficiency from going from 4 GPUs to 256 GPUs was 95%. There was only a loss of 9% in efficiency. This is really, really good. Also, from IBM research, well, I have to explain this a bit more, because the first ones that we have seen, large memory support and DVL, they are focused in deep learning. However, in artificial intelligence, not everything is deep learning. We have other approaches, and they are or they have been running in the CPUs of our machines forever. So IBM Research created SnapML, which is a framework that can be used as a scikit, and it has exactly the same API as scikit, so it's really very fast can be used very fast. And it allows us to run, for example, logistic regressions, linear regressions, several other regressions, support vector machines, decision trees, random forests. It allows us to run them in the GPUs, creating accelerations like 3 times faster, between 2 and 4 times faster in decision trees, random forests. So those are the 3 main technologies that I wanted to explain you that have been used in those supercomputers. Also, as an example of the use of all 3, I wanted to show you another example. We approached Google and we bet them to make a training. And we told them, hey guys, we bet you that we can make this training way faster than you can. And they took in 89 servers from their Google Cloud, and we told them, okay, we will make it faster, but just with 4 servers, 4 of our servers. The trick here is that we were using all 3 methods that I just explained to you. Large memory support, we used DDL, and we used SnapML. By using those 3 tools, we were able to run it 46 times faster. We were able to go from 70 minutes to 1.53 minutes. As always, please, this is a poster example, so don't expect all the workloads to be accelerated 46 times faster, but it's one very good example of what can be achieved with this technology. And who knows, with a bit of optimization, maybe your workloads could be accelerated even more. Now, I will just go for a small and very fast summary of our solutions. Just wanted to tell you that our open power solutions have been in the market for a huge amount of years. We are really, really well seated in this industry, and all the solutions that we are providing now are based in the open power work. The Open Power Foundation is something that it's under the umbrella of the Linux Foundation. So all the hardware that we are creating is absolutely open source. This is really important for many government companies, at least here in Europe, and probably all over the world too. And it's starting to be really important also for the private companies, because nobody wants closed software or closed hardware anymore. Also, those solutions are really, really secure. Just as one example, well, we have something called hypervisor, which could be seen as one operative system, and it has been detected only one hypothetical security breach in all the years it has been in the market, which I think it's 20 years. However, the rest of our competency is not so well in the photograph. Also, with our solutions, we cover all the AI world, from training to inference. And you're going to see right now with the software demo that I'm going to try to run, how it's true. This is a summary of the summary, let's call it. I won't go through it because I just want to go to the software side, otherwise we won't have enough time. Lately, IBM is promoting something called Cloud Pak for Data, which is the tool or set of tools that we are trying to incorporate to this AI market. It has a huge amount of software components. Some of them I know them, some of them I don't know so well, but they are there and they can be used inside this type of solutions. Also, this Cloud Pak for Data, one of the benefits of using it is that it can access a huge amount of data sources. And this is critical for AI workloads, the data that we are going to use to create our models. For example, one of example of this is SAP HANA. Okay, we could use data in SAP HANA, which is something very useful in a lot of companies in Europe, and probably all over the world too. And it covers the whole life cycle of one AI workload, from the beginning where it's stored in one big database to when we put it into production. And instead of talking about this, because I know it can be really boring, I'm going to try to show you how this is true. Okay, sorry, Ganesan, can you see now one black screen called Welcome Admin?
Yes, Sander. Go ahead, please.
Please go ahead.
So this is the admin control dashboard for this product. And I'm going to run a very, very small example, but probably you will be able to see how easy to use it is. I have seen that one of the questions was that people in healthcare, maybe they are not so familiar with AI. So you will see how this type of tools are really easy to use and can make good results. But let's see. I have one project here already created. This is located in our data center in Madrid, in Spain. And I have added several data sets to run this demo, okay? I have selected diabetes, the demo, because I think it had the most comprehensible data set. At least we can see it. It's just, the data we are going to work with is just one Excel file. And it has, well, I took this from Kaggle yesterday, and it's showing us it covers one ethnic community in northern United States. And it shows women and predicts if they are going to develop diabetes in their lifetime. So it shows several data or features, how we call it. For example, showing how many pregnancies they have had, the glucose levels, blood pressure, skin thickness, insulin levels, body mass index, whatever, okay? Several features or several attributes. So let's go back. And what we are going to do, and this is something really important, because when one AI project starts, it always crashes against the technical stuff, me included, because we want to start thinking about how could it be better started. Well, we have something here called auto AI experiment. And this mainly is AI trying to run AI. For example, let's call it Smart Villages Movement Test. Create. And with this, we are going to add this diabetes dataset. It's loading the dataset. It's already loaded here. And we are going to select the column that predicts if the person is going to develop diabetes. Okay. Now we can run the experiment. This experiment takes around 3 minutes, okay? And it shows with very fancy graphics here. I already have it, should have it here. Yeah, this is how in 3 minutes, as you can see here, it finishes. And it shows us which are the best methods for creating one AI that could predict if those persons are going to develop diabetes. Those methods can be very well checked here with all the data that one AI project needs. And also they can be classified by different points of view, from the accuracy, average precision, accuracy, F1. Well, we have different ways of selecting them. But once we have them selected, we can create a notebook to explain that will explain how we have achieved this, this method, okay? And also, we go here, it allows us to put it into production. We can save the model that we just created. Now we have to move it to the deployment space. Everything is right, yes. Well, and once it has been promoted, it takes like 1 or 2 minutes to, it will show us something like this. We can use this training method in online mode or batch mode. For example, if we are trying to, I don't know, to detect melanomas, as Clarice said in her first presentation, in a lot of people, maybe we don't want it to be online, but because as it's a lot of photographs, we want it in batch mode, and we can do it during the night. But maybe we want it to be just online because we have this need. So we go here, and this tool will give us directly the code that we have to embed into our software solutions to start using it right away. As you can see here, it's accessed by one URL. So it can be accessed by anywhere in the world just right away. Also, it can be used by curl, by Java. It has slightly more code, Java. Also with JavaScript, with Python, Scala, whatever. But even it allows us to make some quick tests. For example, one person with 3 preferences, with level of glucose, and I have no medical skills, so I could be saying any stupid thing, 100. Blood pressure of 145, skin thickness of 200. Oh my God, I think I'm gonna kill this guy. Body mass index of 21. Diabetes pedigree function, I have no clue what it is, 89, and age 45. It will predict us immediately with a value of 0, meaning that it's going to predict and which is the prediction, the probability of not developing diabetes with 189.6%. Okay, this tool is, as you can see, it's very easy to use. it's not meant to be used for a whole project, meaning that it also needs data scientists, it needs a lot of work, but it allows us to create quick starting points for those projects, which usually takes months, and it takes with this tool just minutes or hours in the worst case. And well, this is all I had to show today. Thank you very much, and I give back the control to the panelists.
Thank you, Ander. I think this is a good presentation, and also with the demo, and it's very good. So, are you using some kind of the cloud pack for data kind of feature here? Hello, Ander?
Sorry, I was in mute. Sorry, can you repeat the question?
Are you using the cloud pack for data kind of a feature as part of this demo?
Yes. Actually,
okay.
this is part of the cloud pack for data.
Okay, and it's a Power 9 system, right?
Yes, absolutely.
Oh, very good. It's an open Power based Power 9 system. Yep. Audience, participants and panelists, the demo is very interesting, and we do have the Power 9 system, the open Power system available for research, and also students to come and collaborate on our platform and develop prototypes and solutions also. And some of the universities are providing this kind of access, and you can send me an email if you want to run any special program or anything on Power 9 system. And this is a great opportunity from us, to provide this kind of infrastructure too. And any questions from the panelists and from the participants for Ander, or for the whole team, the Clarice?
Yeah, Dr. Ganeshan.
Yes, sir. Go ahead.
I mean, Dr. Ander has given a very good roadmap of the power process technology in terms of the leverage of artificial intelligence in a broadest concept. I think that is one of the things, and the cloud packs integration is a very good contribution in these areas. And it is what is mentioned is the distributed training is one of the issues that has mentioned, which is faster. That is very interesting, and maybe there will be some questions from the active workers who are doing on distributed training, how it is this framework is increasing this the speed, or how it is faster by about, I think it is 46 times or something was mentioning. I think that is very interesting, and essentially what in continuation of what Dr. Ganeshan was mentioning, as a member of the Open Power Foundation, let me say it is an open, not-for-profit organization, Open Power Foundation, and the goal is to create a wonderful, some sort of an ecosystem for sharing the technical expertise. I think it is a computing platforms based on NVIDIA's GPUs and power CPUs. So it is a great opportunity for the Indian students to participate in this innovation through open collaborations, etc. I certainly join Dr. Ganeshan in welcoming these issues, particularly the focus you mentioned on the connectivity between the memories. These are some of the very specific issues what the leading number one company in 28 years, what has been told by Dr. Ander, is particularly the hypervisor and the connection between the memories, etc. I think these are the things to be taken advantage, and there are certainly I think Dr. Ganesh has already circulated a sort of a invitation for the students, for the institutions to participate in IBM Power AI, HPC, and Cloud Center applications. They have a center of excellence. I think that's what is issues. And certainly they're interested in working with universities, startups, etc., in bringing out the technology in general AI. As Dr. Anisha was also mentioning, this is a area where you need a lot of data. Artificial intelligence requires a lot of data, and unfortunately, this is one area where we don't have much data. I think how do we create the data? That could be the one of the problems which medical doctors has to help in this promotion of the technology. These are the two issues I would like to mention for the moment. And again, if any other opportunity comes, I'll join again. Thank you for the moment.
Oh, thank you. Thank you, Dr. Muralkrishna. And any other questions, any other thought process? Dr. Anisha, any questions for Ander? Anything you want to collaborate in Europe?
So let me just...
Mr. Ganeshan, this Dr. Vincent. Yeah, sorry, sir. Please, sir.
Yeah, please go ahead.
Go ahead. Go ahead.
No, it's a wonderful presentation by Ander with the demo. I think I am a professor here, and we work with the research of machine learning and as well as deep learning problems. When doing a machine learning, I think we do SVM classification. I think is demonstrated in IBM how the classification and as well as the regression analysis and the predictive analytics is done. But we used to work with the MATLAB, and I think it is a wonderful opportunity to see this IBM power the Power 9 tools. They really, I think we can collaborate with Mr. Ganeshan to give some demo again for our research students, so that this classification and other things, prediction and regression analysis could be done for our research purpose related to the medical or other in the rural projects or any other projects. So thank you. It's a wonderful presentation by the Ander. Thank you, sir.
Thank you, Dr.
You're
Vincent. Thank you. And please go ahead, Dr. Anil.
Yeah. So this was a very good presentation. The predictive models are very important, and it tells you what the impact could be. And impact studies are very important to demonstrate what can be achieved. And therefore, dollars can flow when you know what the impact can be and what should be. And when you achieve the goals, it makes a tremendous difference. Now, what is important is that in this AI and in the setting of India, urban as well as rural, I think the students have to be encouraged to participate. And one of the things that may be important to speak about is how this thing would help the students take a career in AI in healthcare. What jobs are available? How many are available? Is this the right thing to do? Is there a lot of scope in it or not? How can we achieve that situation? What are the use cases for the huge impact that it can create? Use cases and models are also important to speak about. And I think to a good extent, Mr. Ander did take care of that. But I think what's important is that I don't know whether the students are able to understand the depth of what the opportunities are for the future. That can be addressed.
But this is Clarice. Let me say a few things on that in terms of comments for the students. One item that one experience that we have is that AI can be in conjunction with subject matter expertise. So if your students are interested in healthcare, they can pursue the healthcare line of study and augment it with artificial intelligence education. And it doesn't have to be detailed math theory of how it works and why it works. It can be very pragmatic and applied. And so I would encourage them to get hands-on experience, run different use cases, in particular visual models are very easy to develop in the sense that there's a lot of tooling now to automate those algorithms and to provide some best practices on implementation, and to continue to hone in their subject matter expertise so that they can apply the AI efficiently. And for that, there's definitely online resources and courseware. There's a lot of Fast AI, for example, I recommended in one of the Q&As, runs on our power systems, has a number of tutorials on different types of algorithms to learn from. And then basically pick an example and then think about how to expand that example. So there was a melanoma case we showed. Where else could a vision model give you instant feedback, and then start developing ideas from there.
So one of the things that SmartVillage movement has done is that we've got a educational platform where we want to give students a roadmap of how to have a job eventually. So one of the things that we want to do is to take a student, maybe he's in the 10th grade or so, or 11th grade, and say, okay, this is the pathway that one should take in order to achieve a particular kind of a job. And keep on building on it, because obviously nobody wants to suddenly become a super specialist, but there is a possibility of going through the courses one by one, and obviously then hinge it to a job opportunity, so that a student who's entering into this field has a motivation at the end of the day that this particular job could be available. Obviously, nothing is guaranteed except for the performance of the person, and that is a multifaceted situation in interview. But what SmartVillage movement is trying to do is trying to take large companies and even companies that are participating as partners with us to create the courses that can be put together to create a job opportunity. And we would link those companies into our website so that when they achieve a particular target of education, there's a possibility of a interview to go to have the job taken care of. And obviously, nobody wants to put in the dollars and the hours unless there is a reasonable expectation of getting a good job. So I think that's something that we need to, because nobody, I think a student does not know whether he can end up in a sustainable, kind of a job posting or not. And that's really because so many students are now graduates and postgraduates, and they don't have the kind of job that they think that they were going to get, because the competition as well as the job opportunities are not there as much. So that's an important thing to solve for the student's perspective.
Yeah, Dr. Ganeshan, can I just add 1 minute?
Yeah, please go ahead.
Yeah, I mean, what Dr. Anisha raised a very valid question is regarding the career for the people who are specializing this part of the technology. I view in a slightly different manner. I'm not looking AI application healthcare alone. AI as a broad discipline is the technology that has got immense scope for applications and employment and career building as overall under the data analytics, etc. And with reference to the application related to the healthcare, there are an enormous scope for particularly image interpretation, virtual health assistants, something sort of a development, and what you call as robo-assisted surgeries, processing, etc. There is good demand, but ultimately, or broadly speaking, I consider a specialist of artificial intelligence, whether he's working for health or agriculture or any other manufacturing or supply chain management. These are some of the areas in which the application is dominating. AI can support the 3 important needs irrespective of the domain, which is the need of the future development, and the person will be in great demand, particularly for automating the processes. AI can be used for automating the processes. That is number one. And also gaining some sort of a insight through data analysis. That is what exactly is going to happen. So for example, prediction of a tumor, can it be done systematically few years before based on a continuous series of the data with reference to health application? So that type of gaining insight through data analysis. And third one is engaging with the people, the customers, etc. These are the three important needs which can be addressed by the artificial intelligence community specialist, irrespective of the domain, with enormous opportunities. As we see the need everywhere for automation or gaining insight for data analysis or engaging with the customers. These are the three things I view. And I think that is what we should say. We should not make a specialist in a specific domain. He should be a specialist in artificial intelligence applications, whether it's machine learning applications, overall data analytics, and he will be having great demand everywhere. That's my thinking. Thank you.
Thank you, sir. Thank you, Dr. Murli and Dr. Anisha and Clarice for the detailed explanation, where and when AI could be used and what are all the advantages and all. I think still there are a lot of questions, floating here, and I'm very happy to see, also most of the questions also answered by the panelists and speakers, and I really appreciate it. And any more discussion topic and any questions? Anything you want to bring it up? I know we spent more than 100 minutes here, and it's a great, opportunity for people to interact with all the leaders in the world, around the world. And participants, any questions from your side? Again, you can raise your hand, or you can open up the question in Q&A.
I see a question on accuracy.
Yeah.
How much of this prediction is accurate? Can we rely on those results predicted by the AI? So this is a very, very important topic in terms of what accuracy means. So depending on the use case, you're going to have different targets relative to accuracy. And accuracy may mean different things to different scenarios. One of the easy examples we give is in autonomous driving. 80% accuracy is not good enough, right? It has to be nearly flawless for the confidence to be able to put just the machine at the wheel to drive, right? In some scenarios, you may have a case where it's just a first pass of determining whether you need additional tests or something, in which case there's no hard, difficult consequence if you're wrong, and it will be adjusted at a later time. So depending on your requirements, you're going to build a model to reach a certain level of accuracy if you can. If you can't, then it's not a good fit, and it's just a starting point. And then determining what's important to you is the other aspect of this. So, for example, in the case of the credit cards and determining fraud, some companies would prefer to err on letting a few go by versus having a large number of false negatives or true positives. So looking at what your criteria for accuracy is very important. So that's pretty much how data scientists approach it. They have a goal, they look at what metrics need to be applied, and they iterate until they're confident that their models are accurate enough and also tamper resistant and secure enough and explainable before they go into production and deploy any given model.
Thank you, Clarice. Any more questions? I think, hold on, let me see. Yeah, yeah, thank you. I think, it's already answered. And if there is any more question, please do send us an email. We can also answer through the email too. You all have, the email ID for this, the Open Power Foundation, the academic discussion group. And, you can send the email to us. And certainly, we can help you out in that. And with this, I want to close the session. But before that, thanks for the speakers who stayed with us for more than 100 minutes, and also did a lot of time presenting and answering questions, especially Clarice, for spending her time, most of the time, a lot of time in our Open Power webinars. I really thank you, Clarice, for your wonderful presentation and answers, detailed answers, for the students and faculties and industry experts. And also, Ander, thanks for presenting and also with the demo. And this is very useful. Definitely, it's going to be a kind of a starter for many students worldwide. I do see people join from Kenya and Dubai also. So, it's not just India only crowd. So this is a venue where a lot of people can jump in, and collaborate on that too. And thanks for that. And also the panelists who spent more than 100 minutes, being with us and answering questions, and also discussing about the topics related to healthcare and AI, how that could help the society and all. These are all very interesting. And also in the partner and the collaborator, like for this webinar, SVM. I'd like to thank Dr. Anil, as well as Dr. Murli, for the wonderful participation as well as initiatives. I really appreciate it. And with this, I'd like to close the webinar. And if you want to say a few words, please go ahead and share it with all. And and thank you all for the wonderful discussion and the topics also. Thank you very much.
So, Anisha, just to say the last word here.
Yeah.
That, Smart Village movement, of course, is a movement, and movement cannot be a movement unless there's a participation of the people. And therefore, we welcome the participation of everybody at any stage, with a variety of different things that they could do. So go to our website, www.smartvillagemovement.org, and try to register yourself and see the grand challenges and all the different things that we do. There are courses that are done. We are in alliance with University of California, Berkeley, the Berkeley Haas, and it is a perpetual relationship that we have with them, by which they support the research on the ground, as well as all the corporate contacts that they give us, and all the major great research that can be done. I mean, just an example is how do you remove arsenic from the soil? That's one. It affects about 100 million people in India, and it's on the groundwater. So how do we really do that? These are the kind of research projects that we want to undertake in the future. And participation of people on a voluntary basis. We all do work voluntary. Of course, we have got a full-time staff that's paid, but most of our work is done voluntarily, and we encourage the participation of people to help us out in any different ways to create these smart villages in India. Thank you.
Thank you, Dr. Anisha, and really, I welcome the smart village movement, and it could be applied to the worldwide also, and let's see how we can take it to the the next level in collaboration with IBM, Open Power, and the many members as part of the Open Power Academy and Research worldwide. And with this, I'd like to I'm closing the the webinar. And thank you for all the participants, panelists once again, and also the speakers. And and have a good day and have a good evening to all. Thank you.
Thank you. Great work. Bye.
Thank you. Thank you very much.
Thank you, Dr.
sir.
Ganeshan. Thank you, Dr.
Yeah,
Ganeshan.
thank you,
Wonderful,
Dr.
wonderful,
Ganeshan.
wonderful.
Very much.